All right. So chapter 10 is about chemical bonding, and we got a really good start talking about this in lab last week. So some of this will just be sort of extra practice from the structures that we were drawing last week. So in general, what's referred to as a Lewis electron dot structure is really just anything that shows valence electrons. Okay? Even just for individual atoms, we can draw Lewis electron dot structures, whether it's metals or nonmetals or anything, as long as we just draw dots for those valence electrons. So here's a magnesium. How many, here's our periodic table there. How many dots should I draw on that magnesium? Right there. Okay. So let's give it 2 dots. We're not going to be too particular about where dots are drawn just on these atoms. Okay. But let's make this a neutral atom. That means it just has its valence electrons just like it normally would. Okay. What about the chlorine? How many dots? Right there. Okay. So let me use a different color here. 1, 2, 3, 4, 5, 6, 7, something like that. Okay. So these are both neutral atoms. But they're not stable. We talked about this a bit in chapter 4. Just because something is neutral does not mean it is stable. If it is neutral, that means it has all the same number of pluses and minuses inside the atom, so it has no charge. Okay? But to be stable, what has to happen to an atom? What did we say about valence electrons? We actually had a rule about valence electrons for things that are stable. Somebody said it. The octet rule is what makes atoms stable. Okay? So it turns out the arrangement of electrons, just like we saw in the last chapter, filling in empty spaces in those orbitals, okay, to get totally full orbitals, that can make an atom stable, or getting rid of sort of leftover electrons that are extra within a shell, that can make an atom stable. Okay? So this neutral magnesium atom, it's not stable right now, because it has those 2 valence electrons that are in a shell, right? But the octet rule says that magnesium as it is not stable. So what should that magnesium do? It's a metal or non-metal? Magnesium. It's a metal. What do metals do to their electrons? They gain electrons, they lose electrons, right? Because you can see just from our very simple picture here, it has 2 valence electrons that are sort of left over. They're excess. Okay? There are several filled shells sort of underneath that, and then we've got 2 more on the top. So if that magnesium got rid of those 2 electrons, it would be in a much better place. What does chlorine need to do to become stable? If we've got 7 dots shown right there, it needs to gain 1. Okay? So let's do a little electron transfer here. Let's take one of these and give it to chlorine. Okay? That makes a chlorine with now 8 valence electrons. We're just going to draw a circle around that. So this chlorine will have a charge now because we gave it an electron, right? What charge will this chlorine have? Electrons are electrons are minus, right? We gave that chlorine an electron, so that'll be a single negative charge chlorine, right? But that still leaves this magnesium with 1 electron, 1 valence electron that it still wants to get rid of. So what's it going to do with that valence electron, do you think? And it's not just going to disappear. It's not just going to fly away. It has to give it to something. What do you think it could give it to? Yeah, let's draw another chlorine. Some of you are saying you can do that? Oh, yeah. In fact, there has to be another chlorine over here, otherwise that magnesium doesn't have another place to get rid of its electron. Okay? So what we end up with here's another chlorine. Let's draw it over here. 1, 2, 3, 4, 5, 6, 7 of its own. Okay. Here's the 8th one that it just got, so there's a minus charge. Okay. And that magnesium then got rid of 2 electrons. So what kind of charge will it end up with? 2 plus. Okay. Let's draw an Mg2 plus right there. Okay. Let's put a big box around these ones. Okay. Because here we have 8 valence electrons. That makes that a stable ion. Same with this one. How many valence electrons does that Mg2 plus have? Yeah, it actually has 8. I mean, you could say 0, I suppose, because we don't have any dots drawn, but why is 8 also a way of thinking of that? Yeah, we got rid of, right, the valence shell was the one that had these 2 electrons in it at that point, but now that that's empty, now the previous shell becomes the valence shell. So now there's 8 valence electrons in the previous shell. So that makes that stable too. Okay? Now, what ratio of magnesium to chlorines did we need in order for all this electron transfer to work out? Yeah, we needed 1 magnesium to transfer all the electrons. Okay? That's why magnesium chloride is MgCl2, something that we already know how to do, but now we can actually sort of track where those electrons are going. If we started with just 3 of those neutral atoms, they would transfer electrons, and we would get that ionic compound. Okay? It's ionic because metals lose electrons, nonmetals gain electrons, so we end up with plus and minus ions. Okay? This is an ionic compound. Right. What actually holds an ionic compound together is ionic bonding, the attraction between those oppositely charged ions. So if we redraw the chloride ion over here, a chloride ion over here, a magnesium ion right there, they're oppositely charged, so they're going to be attracted. Okay. So what holds magnesium chloride together is the fact that first the electrons transfer to make those stable ions, but then because those ions are oppositely charged, they stick to each other. Okay? Now, the reason ionic compounds are so different from molecular compounds is that there's no direction to that attraction. Okay? Mg2 plus will be attracted to anything with a minus charge sort of in any direction. So we don't end up making just a molecule of this. We don't just have a magnesium with 2 chlorines next to it floating around and then another one like that. They're all stacked up all together in an ionic lattice. And that's something that we saw a picture of a long time ago, but we can just draw a little picture here. We draw 5 like that, and then some other ions with a different color in between. Okay? Alternating, stacked ions that make an ionic compound. Okay? And that continues on sort of in all directions. So we could talk about a formula unit. What we've got there, that magnesium and 2 chlorines, that is a formula unit. We've talked about those before. Okay, that is a formula unit. of MgCl2. It's not a molecule, though, because the actual structure is a lattice with all those ions all stacked up until the very end of the structure. Okay? The name's bond, ionic bond. Taken, not shared. What are we talking about there when we say taken, not shared? What is taken and not shared? What do you think, Jonah?
Borrowed without permission.
Yeah, so what? What was taken? Ah, the electrons were taken. Yes, without permission. the transfer of electrons happened right here. The metal gave away electrons. The nonmetal accepted those electrons. Okay? Electrons, another way of saying that is electrons were transferred. Okay. To make an ionic compound, okay? The ionic bond is then the attraction that those oppositely charged ions have for each other. Okay? Does that make sense? Anybody have questions?